Hey, welcome back to the tutorial. In this lecture, we will talk about the convention used by Priortos in defining the variables. Let's look at what are the convention used for variable declarations. Variables of type unsigned long are prefixed with ul, where u denotes unsigned and the letter l denotes long. Variables of type unsigned short are prefixed with us, where u denotes unsigned and the letter s denotes short. Let's check this convention directly in the source code. Okay, let's go back to our Atmel Studio where we did our first application. So this is this was our first Priortos application which we executed on the hardware. So let's understand. So what are the variable convention used in the Priortos kernel? For example, let's see what is the convention used in this function. For example, let's go to this function. I'm just going into the Priortos code very randomly, so don't worry about all this code or all these source files. So this is not the right time to explain all those things. So I will cover in detail all this Priortos related files as well as the folder structure in later lecture. So this is just to understand how the variables are declared and what are the convention used by Priortos. Okay, let's understand this. US stack depth. This is a variable of type unsigned short, isn't it? So since it is of type unsigned short, the variable is prefixed with the letter US. You can see here. So by just looking at this variable, you can come to know that this is a unsigned short type, isn't it? So let's move further. You can see here PV parameters. Okay, by just looking at this variable, you can come to know that this is a void pointer. So when you encounter this variable somewhere in your code, then you can easily identify that it is a void pointer. Now, variables of type unsigned char are prefixed with uc, where u denotes unsigned and the c denotes char. So if you find a variable name which is prefixed with the letter uc, then just think that it is of type unsigned char. Variables of non-std int types are prefixed with x. So this is a very important point. Okay, so if you encounter any variable whose prefix is x, then it is not a standard int type. That means it is not defined in the stdint.h. Okay, so it is a user defined data type. So let's go back and check to see whether, for example, consider this variable here. It is prefixed with x. That means x regions is not a standard data type. So it must be a user defined data type. Let's see where it is implemented or declared. Okay, here it is. So this is a pointer. Okay, this is actually a pointer of type x memory region. Okay, so x memory region is nothing but a user defined structure. Let's go to its definition. Here you can see x memory region is actually a user defined structure. Okay, so which has three members. One is a void pointer, so that's why they have prefixed this variable with the word pv, void pointer. And this variable is unsigned long, so hence they have prefixed this with ul, and this is also an unsigned long data type, so hence this variable also prefixed with ul. So So if you encounter X, then think that it is of type user defined, okay, not a standard data type. Okay, let's understand one more example. Okay, let's understand this line. So here X item value is a variable and port tick type is data type, isn't it? So first let's check this. So here it is prefixed with X, isn't it? So that indicates that this variable is not standard data type variable. So what are the standard data types? Int, float, char, double, etc. So this variable denotes that this is not a standard data type which is defined in standard stdin.h, okay, or whatever. So this X indicates that it is a user defined data type, okay, and user defined data type could be anything. So in this case it is port tick type, okay. And an interesting thing here is, look at this data type naming convention. Here they have prefixed this with port. That means this data type is architecture specific data type. So this data type should be found in port.h or port macro.h. So just looking at the data type, you can come to know that where it must be defined. For example, right click on this and say go to implementation. Here you can see it is already showing this is defined in port macro.h, and it is also found in port macro.h in okay, so this is found in two places, okay, of the file port macro.h. So you can go there and you can check. Here you can see it is defined with a condition. That's okay. So that's the beauty of FreeRTOS naming convention. So the same technique you can use in your project or in your work also, so which gives more structure to your code. So let's move further and explore some other. Here you can see, let's understand this line. Here you can see this is a variable name, isn't it? PC name, okay. Here prefix is PC, right, where P says that it is a pointer and C says that it's a character. So collectively it is a character pointer, but it's a constant character pointer to a constant data. So whether it is a constant or it is not a constant, that information is not given in the prefix. Prefix only tells you about whether it's a pointer or not, or whether it belongs to a character or int or whatever. So let's move further and look at this variable. Here, by looking at this variable, I can tell that it is a pointer to a void. It's a void pointer, right? So let's move ahead. Unsigned variables of non-stdin types have an additional prefix u. Enumerated variables are prefixed with e. So if you find any enum, so those variables which belongs to enumeration are prefixed with e, where e describes it as enum. Pointers have an additional prefix p. For example, pointer to a uint 16 will have prefix pus. This we have already seen that p indicates it's a pointer variable. So if it is a pointer to an unsigned short, okay, then it is prefixed with pus. So that's the naming convention they have used, and the same convention you can use in your work also, which gives more structure. Thanks for watching.